This is your brain on risk. This is Mind Over Money, the podcast where Kevin Cook exposes the psychology of investing.
Welcome back to Mind Over Money. I'm Kevin Cook, your field guide and storyteller for the fascinating arena of behavioral economics. Since I'm an investor in an exciting technology company you may have heard of called Nvidia, I often find myself in the position of having to explain to my followers and fellow investors what exactly is AI, or artificial intelligence, but in a practical, right now sense and not some science fiction sense. So today's podcast is going to be valuable to you if you are an investor in any high-tech companies, and more of them, even if they don't produce AI chips like Nvidia, they'll be buying them. And I actually have a breaking story just today. Facebook and Intel came out with a press release talking about their partnership on an artificial intelligence chip. More on that coming up. But even if you're not an investor in any of these companies, if you're just a citizen who's curious about AI and how it's going to impact you, especially with companies like Facebook and Google using it, and it being the brains behind autonomous driving, this is going to be a valuable podcast, and I hope you learn a lot. So let me describe Nvidia a little bit and why I'm an investor in that company. Their type of computer chip is called a GPU. The chips that Intel built that run all of our computers are called CPUs, central processing units. And Nvidia invented the graphical processing unit initially just for video games. But then they found it had a whole lot of other applications, especially as it kept evolving. So these GPU chips are at the heart of modern artificial intelligence research and development. And Nvidia sells a lot of them, not just for advanced gaming graphics, but also to industry applications. Autonomous driving I talked about. I believe Tesla, Toyota, and Mercedes are all customers and partners with Nvidia using these chips in their platforms for autonomous driving or assisted driving. Nvidia also has a bigger business selling their processors to big cloud companies like Amazon, Google, Microsoft, IBM, and Alibaba. In fact, Nvidia's AI chips powered IBM's Watson. IBM and Nvidia have been partners for a while, and so IBM uses those chips. And just to give you an idea of Nvidia's business, it's still over 50% of their revenue is selling these chips, these GPUs, to the gaming industry, which is a $100 billion industry. And I hear that at $100 billion, it's the world's largest entertainment industry. And then about a quarter of their business, the next biggest segment, is selling to the cloud companies, big data companies that have a lot of data and want to analyze it in a meaningful way versus having humans do it. Computer can handle a lot more data a lot quicker. And so we talk about the cloud, data centers, supercomputing. That's the realm of companies like Amazon, Google, Facebook, Alibaba, and many of them use Nvidia chips. And the autonomous driving part of so Nvidia's run rate for the revenue right now is about $9 billion this year, and they'll do $10 billion next year. So that's the breakdown I'm giving you. Right now, autonomous driving, the auto market is only about 8% of that $9 billion, but it's also growing pretty fast. But the segment that's growing the fastest for Nvidia is the cloud center because of what these companies want to do with big data. And it's estimated that that's growing at over 50% a year. So just incredible growth there. And that's why the stock is headed towards 200. That's why we own it. And then about 15% of the revenues is, stuff you really don't hear about or see every day. It's industry, doing things like machine vision and certain learning and AI applications for factories. And I call that a sort of silent productivity revolution that's going on as things become more automated. So what is it about these chips that are so different and can create a computer that can beat a Texas Hold'em poker pro? I did a video on this back in March, and I called it Get Your MPA in Deep Learning. And MPA stands for Massively Parallel Architecture. The whole idea behind these GPU chips is that you use thousands of them at once. So if you picture a large computer that has a lot of processing power where the chips are made by somebody like Intel, it might have 6 core processors. And they have a defined way of handling information. Of course, they can crunch a lot of data. But the idea with massively parallel architecture is that you have thousands of these cores all processing information simultaneously. So that's the power of GPU. And you may be familiar with Moore's law, this idea that's actually was a prediction in the 60s from somebody at Intel and has become reality, how every 18 months chips shrink in size by half, and size-wise and price-wise, and just become more efficient and smaller. That trend is starting to level off. We're not getting quite the same return from traditional CPUs, but GPUs is the next evolution, and it will create. Nvidia estimates that by 2025 we'll have 1,000 times more power and efficiency, even as size decreases. And so that's their prediction, and they seem to know their stuff for the markets they work in. So, and obviously the AI chips from Nvidia have applications to other industries like healthcare, medicine. I don't think anybody wants to be diagnosed by an AI bot, but the tools that AI and deep learning can provide to physicians and medical researchers are just incredible, and I know that many of them are very excited about it. So my objective today is to explain what terms like machine learning and deep learning mean and what their applications can be used for. My introduction to this was a company called Mobileye about 3 years ago. Mobileye is an Israeli company that came on the scene with creating the brains for autonomous driving. They had what they call a system on a chip that could see the road with cameras, identify objects, and then tell the car what to do. And that company was bought this year by Intel because Intel didn't have an autonomous driving system on a chip, and so they just went out and bought one. They paid about $15 billion to buy the Israeli company Mobileye. And that symbol, the stock, I don't think the deal is closed yet, so you can still see that stock trade. MBLY is the symbol for Mobileye. And Intel is INTC, Nvidia is NVDA. So a little disclaimer, I am not a computer scientist or engineer. I'm just an investor who's fascinated by technology that changes our lives or that solves uniquely challenging problems, even as it invents new ones. And that's the thing about technology is we solve one problem, we always create a new one, but that's the path we're on. So I don't pretend to be an authority on AI, machine learning, or deep learning. Consider this podcast an experiment where I'll attempt to highlight the unique aspects of these exciting technologies. And this is such a big topic, I'm actually going to make it a 2-parter. So this will be part 1 because I know I won't get through all the awesome stuff I have for you today. And because the science is so exciting and there's so many companies doing so many cool things, this could fill hours of podcasts and I'd never get bored anyway. So I hope this first episode that you feel the same way by the end. I'll be reading from some articles on the work of computer scientists who solved a particular puzzle. And I will tell you where you can find the source articles and scientific papers for them, like the Nvidia blog and their podcast. And so you'll want to mark down these resources. Now, if I should screw something up about the science of AI and deep learning, or I could have explained it better, then I expect to hear from you. You can email me at kcook@zax.com. And if you are an AI expert and you want to be on the show, also give me a call to help me clear the waters I might have muddied. All right, so today's deep dive here begins with a poker blow-up. It's interesting, the AI work with poker that I'm going to share with you, I just accidentally discovered this podcast and this work from Nvidia and researchers at the University of Alberta. I just found it on Monday by accident, just searching some things on the internet. But I had just spent the weekend watching some poker video, some YouTube videos of like Championship Poker, World Series of Poker, World Poker Tour. And as you may know, I did a podcast a couple weeks ago on October 3rd about Daniel Negreanu. I also did a video that same week where I tried to connect what Daniel Negreanu is so good at with poker. Many of us try and do in the stock market. We're playing the player. And the title of that video is Gaming the Stock Market with Poker Smarts. Well, the videos that I focused on this weekend were of Phil Hellmuth. His name is spelled Hellmuth, Hellmuth. And Phil Hellmuth is a interesting poker player to watch because he's very different than Daniel Negreanu. Whereas Negreanu is having a good time, joking, seems to be pretty even-keeled. Hellmuth is famous for blowing up, both emotionally and his chip stack. And I watched several of these incidents he's had over the years, from tournaments 10 years ago, 5 years ago, even a couple years ago. And I noticed two patterns for Phil Hellmuth. He gets emotionally upset and angry about two things. Number one, opponents not playing in a rationally optimal way. In other words, you find him continuously saying, I can't believe you did that. Why would you call that? Why would you bet that? This doesn't make any sense. So he expects all other players to play in a rationally optimal way. And then, then his way of playing, he'd be able to beat them if they were all doing something rationally optimal. And then the other thing he gets upset about is what I call wild randomness. Poker is going to have its fair share of randomness, and things will happen that seem, like tail events on a distribution in terms of probability, like getting pocket aces 2 times in a row. But it can happen. He'll say things about other players getting lucky cards. How can I play against this guy? He always has luck against me. That kind of thing. And so you can. On YouTube, you can search some of these, Hellmuth's blowups, or pocket aces versus Negreanu, or getting felted. And this behavior got me thinking right away because, the connection I make to trading is that this is the exact kind of stuff that does not work in the market. You will get your clock cleaned and lose your money in short-term trading, and you probably won't have a lot of success as an investor if you're getting mad at the market, if you're expecting everything to be rational, and if you can't handle randomness. Sometimes things blow up or out of kilter, and there is no explanation. You just have to deal with randomness just over time. It's gonna sneak up on you, and that's why you sort of spread your bets and know that if you do concentrate, you can get clobbered. I think right away of an investor I've watched and followed for years, and that would be Bill Ackman, who had several of his own blow-ups, and he seems to just sort of keep doing the same kinds of things where he makes these huge commitments to certain ideas like JCPenney or shorting Herbalife or Valiant Pharmaceuticals, which he bought at $175, watched it go to $250, and then watched it go to $10 and stuck with it the whole time. And so, expecting the market to be rational and not have any wild randomness is a big mistake. When I used to teach beginning traders how to deal with the randomness of the market and also their own emotional patterns and cognitive biases, I actually built a probability simulation because I thought that if somebody can internalize how probability will work for them over the long run, if they just make probability-based decisions like you do in poker, that it would help them sort of override emotional impulses and their own cognitive biases. And I used to teach them a phrase: I'm just a surfer looking for the next wave, never blaming or hating the ocean for being itself. All right, I'll be back with how they solved the Texas Hold'em problem and what we've learned since Deep Blue beat Garry Kasparov in chess. I'll be back faster than you can spell Kasparov. This was the big news today from Facebook and Intel. I want to read a little bit from this Wall Street Journal article by Ted Greenwald. He does a great summary. The title of it is Facebook Pitches In on Intel's Coming Artificial Intelligence Chip. So this is Tuesday, October 17th, and it looks like Facebook is providing technical input for a coming chip specially designed for AI. As the semiconductor giant Intel moves to capitalize on a fast-growing market and aims a direct shot at rival Nvidia. So for Intel, this will be among the first of a new breed of processors designed from the ground up to accelerate the popular AI technique known as deep learning, which enables computers to recognize objects in photos, words in spoken statements, and other features that would require human judgment. And this is, they're calling it deep learning, but Google has obviously run search engines for years that can collect photos from the internet and recognize photographs and that sort of thing, and group things together. So, there's been mild forms of machine learning. We talked about email spam filters before, for a couple of decades now, especially as the internet took off. And what we're going to see today, that what is done with deep learning is actually the next level. But Facebook and Intel are pretty glad to be partnering, it looks like. Intel said it is working with a select group of companies to fine-tune the chip. And obviously they highlight Facebook here. The company said the technology could contribute to advances in medical diagnosis, financial fraud detection, weather prediction, self-driving cars, and other areas. An analyst from More Insights and Strategy, Carl Friend, says the market is worth at least $500 million this year, and it could grow to $9 billion by 2020. So obviously Intel wants a piece of that pie. And here's what the article by Ted Greenwald from the Wall Street Journal says about Nvidia. Nvidia serves that market virtually single-handedly. Its chips were designed to process graphics, but proved more efficient in some deep learning tasks than Intel's conventional processors. Deep learning has emerged as an effective way for computers to find useful information in the floods of data washing over the internet and corporate networks, especially imagery, sounds, documents, and other data that isn't in strictly organized formats, such as spreadsheets and databases. However, it requires huge quantities of computing power to process immense stores of data. With deep learning, computers study large volumes of test data for patterns in a phase called training. That's important. In the machine learning, deep learning science, so to speak, engineering, they talk about training and inference. So a computer gets trained on looking at lots of different data and finds patterns, and then its intelligence is then released to be able to do inference. Intel actually, I guess this new chip is going to be named Nirvana, and that's spelled Nervana, which was a company that they bought that was making this type of chip. So that's a good summary. You should look for that news if you're interested in what Facebook and Intel are up to. Now let's get down to playing games with AI. I mentioned before the break, Deep Blue beating Garry Kasparov in I believe it was 6 games of chess back in the mid-90s, and that type of AI was really just still brute force computing, where chess is a game where you walk up, anybody can look at the board and know what's happening. There's no hidden information, and you don't have to know exactly how the pieces got where they are either. You can you play from wherever the game is. So it's a perfect game for a computer to just be able to crunch all the possibilities. Runs a decision tree, and it can calculate a lot faster than a human can and put the odds in its favor. So that was still the old style of so-called AI, which is just brute force computing. Now we step forward into the land of solving a very complex problem, which is poker, where you have limited information. So, poker it's not only a concrete laboratory to do artificial intelligence research, it's a great classroom to learn about the methods and achievements of these AI computer scientists. Now, I'm not a very experienced poker player, and I've never played high stakes, so I can't say that I wouldn't get as emotional as Phil Hellmuth. So I apply my expertise to trading and investing. So let me read for you an article from Science Magazine, which summarizes what they achieved in 2017. Now, before I do, let me just say that you can go, if you're not signed up at sciencemag.org or sciencemag.org, rather, you can sign up for free and you can get access to the first paper that these researchers, led by Michael Bowling, they published in 2015 when they solved the first poker game. And the first poker game that they solved was heads up, meaning two players, only two players, heads up against each other, limit Texas Hold'em. And limit means that bet sizes are limited and the number of times you can raise are limited. So that reduces the complexity of the game. And they had been working on that for 10 years. So roughly since 2006, they had been working on that, and they finally solved it. When they say solved, what these computer scientists mean is that, and I may have to look up their definition to be sure, but it's not just being able to beat a human player once in a while. It's they actually came out and crushed a lot of human poker players with a degree of statistical significance that it was way beyond random. And so when they say solved, they mean that they put an edge in their favor that could almost not be beaten. So that's what they mean. And so in 2015, they solved the first complexity problem, which the way I learned about this was this podcast on that Nvidia does. Nvidia has a great blog, by the way. You gotta go to the Nvidia website and check out their blog and then their AI podcast. So the one that I listened to on this week was it's actually from March of 2017, and the title of it is AI Cleans Out Pros at Texas Hold'em. Now this is the newest version of their monster computer, which solved Texas Hold'em on the no limit level. Now, the significance of that is, you watch these poker tournaments. This is where players can bet anything they want. They can re-raise, they can 3-bet, 4-bet, and they can go all in. So there are no limits on betting or raising. And that element of the rules creates a massive order of magnitude difference in terms of complexity. And just to simplify this, the first problem they solved in 2015 with limit hold'em, heads up limit hold'em, has a degree of complexity that you could describe as 10 to the 14th power. Now, 10 to the 14th power, that's like, I think that's like 10 million squared, which is like 100 trillion. So 100 trillion decision points, 10 to the 14th. When you start talking about the level of complexity and decision points with Texas no limit, or Texas Hold'em no limit Hold'em, meaning you can bet as much as you want, as often as you want. That level of decision points and complexity is 10 to the 160th power, which, that's 160 zeros. That, as scientists will tell you, is a bigger number than there are atoms in the universe. So it's an incredibly complex problem to solve. And I'll tell you how they trained a computer to go from one level of complexity to a massively different level of complexity. Let me read from, the summary article from Science Magazine by Tanya Riley, dated March 3rd, 2017. 2 artificial intelligence programs have finally proven they know when to hold 'em and when to fold 'em, recently beating human professional card players for the first time at the popular poker game of Texas Hold'em. And this week, the team behind one of those AIs, known as Deep Stack, has developed. That's such a cool name, right? Deep Stack. So we had Deep Blue, then there's Deep Learning. What else are they going to name this besides Deep Stack? Deep Stack of chips. Awesome stuff. So the team from Alberta has divulged some of the secrets to its success, a triumph that could one day lead to AIs that perform tasks ranging from beefing up airline security to simplifying business negotiations. AIs have long dominated games such as chess, and last year one conquered Go, but they have made relatively lousy poker players. And that's because of the complexity involved. In Deep Stack, researchers have broken their poker losing streak by combining new algorithms and deep machine learning, a form of computer science that in some ways mimics the human brain. allowing machines to teach themselves. And this is going to get interesting. So some scientist from Deep Blue was praising the program. All right, so games like chess and Go have an important thing in common that let AIs beat them. They're what are called perfect information games, meaning you see everything, nothing is hidden. Obviously, Texas Hold'em is different because you don't see your opponent's cards. I'm not going to explain the rules for Texas Hold'em like they do here in the article. I'll skip that. But we're leading towards something here that they trained this computer to do to deal with this complexity. The aim of traditional game-playing AIs is to calculate the possible results of a game as far as possible and then rank the strategy options using a formula that searches data for other winning games. The downside to this method is that in order to compress the available data, algorithms sometimes group together strategies that don't actually work. So when you think about it, in the first version of Texas Hold'em that they conquered, which was Limit, they could actually train the computer on millions of games, like 10 million games and possible outcomes, and have the computer store all that information in a database and basically have it be accessible in some sort of table to help them make decisions, to help the computer make its own decisions. They couldn't do that for No Limit because, as we talked about, there's just way too much data. There's way too many decision points, and it would take years for the computer to make a decision based on going through all that. So what they did is they simplified. After they taught it how to play, then they started grouping things together. Like I'll oversimplify here, and this could be wrong, but something like a pair of aces is very similar to a pair of kings. And then so you just combine those two cards that you're dealt into the same idea. All right, let me go back to the article by Tanya Riley. So University of Alberta in Edmonton, Michael Bowling is the lead scientist here. His team's poker AI, DeepStack, avoids abstracting data by only calculating ahead a few steps rather than the entire game. So what they play is a couple of hands and decisions at a time. The program continuously recalculates its algorithms as new information is acquired. When the AI needs to act before the opponent makes a bet or holds and does not receive new information, deep learning steps in. Now, there is another computer program, another group at Carnegie Mellon came up with their own AI, Libratus. And both teams say their system's superiority over humans is backed by statistically significant findings because both actually played against pros. And if they played against online pros, if you think about it, we talk about Daniel Negreanu gaming the table and people's facial expressions and that kind of thing and looking for tells. Obviously, the computer can't do that, and that's why it was perfect for it to play against online pros because then nobody's the only information that's being read is what is the opponent betting and what does that mean? What does their betting behavior tell you about the likelihood that they have or don't have a certain hand? But the main difference between DeepStack and Libratus is that DeepStack uses deep learning in a very novel way. And so it can run on a laptop because it doesn't need to access a database, where Libratus was still having to access its database of possible solutions. Now the amazing thing that this gets to, if you listen to this podcast, AI cleans out poker pros or cleans out pros at Texas Hold'em, and listen to the lead scientist Michael Bowling, is that he starts using the word intuition. Here's a computer scientist for 20 years, and he's saying that what they've created is a computer with intuition because that's the way they've trained it. It's just an amazing concept. Now, is it really intuition the way we think of it? Well, maybe for computer standards, it is intuition because of what it's doing. Right now, maybe other scientists would just call it inference, but he calls it intuition. Now, let me just explain the way they trained this thing. In computer science, there's something called CFR. And CFR stands for counterfactual regret minimization. So CFR thing, counterfactual regret. So what they do is they teach a computer to play a game by playing against itself and playing billions of games. And the way it improves over time is summing the total amount of regret it has for each action at each decision point. Positive regret means that the computer would have done better if it had taken that action more often, and negative regret, obviously, would have done better by not taking that action. So there's just some amazing stuff here going on with this AI that finally could crack Texas Hold'em. And I think it means that, if they could train it, build it and train it on a relatively defined problem, which first was limit hold'em, and now the what's called an extensive game of no limit. Just think of the problems that they're going to be able to solve with AI, or think of AI as an assistant. People I think they get worried, they get scared that AI is going to be taking over a lot of decisions that they don't want them to. But really, I think we want to think of it as a tool, as an assistant in all kinds of problems. And you think about security at airports, or security, online, financial securities, financial fraud, cybersecurity, and the possibilities are incredible. So we're going to talk more about this next week, and I also have some exciting AI research for you, where brain scientists are learning to use big data and AI in some amazing ways that I think will help people, especially anybody interested in mental health. All right, thanks for joining me. It's a brave new world, and hopefully we can learn about the technology and have it help us, and not run our lives for us. It's not you think of the dystopian novels, that we read when we were in college, George Orwell's 1984. Aldous Huxley's Brave New World, and technology can definitely become a master instead of a slave. But I think the more we learn about it, the more control we have over it. All right, we'll talk to you next week.